Hello everyone and welcome to lesson 5-6, add linear expressions. This lesson can be found on page 387. Today's most common expression will be linear expressions. So we're going to be talking about linear expressions. Okay, let's start by looking at the real world link. Homework. Luke has 20 math problems and 11 science questions for homework. Cameron has 23 math problems and 10 science questions for homework. Okay? The expression below represents the types of exercises that Luke has for homework. 20 math problems plus 11 science questions, as we have it written on the top there. Right here, math problems and science questions, okay? Complete the expression that represents the types of exercises that Cameron has for homework. He has. Notice they say Cameron. They didn't say Luke. So now we have to look at Cameron. Cameron has 23 math problems and 10 science questions. So we have 23 math problems and 10 science questions. Write an expression for the total number of math problems and science questions for both boys. Okay, so now we're looking for the total. I have 20 right here plus 23 equals 43, right? And for science, we have 11 science problems and 10 over here. So 11 plus 10 is 21. Suppose Luke has X math problems. When they say X math problems, it means we don't know how many math problems. It can vary, right? We don't know. So that's a variable. Suppose Luke has X math problems and 5 science questions for homework. And Cameron also has X math problems, so we don't know what he has, but because they both have X, we know they both have the same amount, correct? Because if they were different amounts, this would be X and this would be a different variable such as Y or any other variable, but it would show that they're different amount. But because they're both X, we know they're both the same amount, we just don't know what that amount is. So he has X math problems and 6 science questions. The algebra tiles below represent the total number of math problems and science questions for both boys. Write an expression in simplest form that represents the algebraic tile. Okay, so we have definitely 2 X's, right? We have one there and one there, one for each boy. And one of the boys has 5 science problems, the other one has 6 science problems. So for sure right now I know that I have 2 X's, right? 2 times X plus how many word problems in total, because they want to, for the both boys, we have 5 here, it's 11, so we have 11 in total. And there's our algebraic expression in simplest form. Add linear expressions. A linear expression is an algebraic expression in which the variable is raised to the first power and variable are not multiplied or divided. The table below gives some examples of expressions that are linear and some examples of expressions that are not linear. So linear expressions, 5x, 3x plus 2, x minus 1. Nonlinear, 5mn, 3x to the power of 3 plus 2, and 4x. Okay, so we have these variables right here are to the power of, to the first power. Okay, there's only one, they're not square, they're not cube, they're only to the first power. Well, here we have cube, we have square, and here we have 2 variables. To me, what this is starting to look like, boys and girls, is that this is when it says a linear expression, it's an expression that can be graphed, okay, on a coordinate plane, because we have an x right here, an x coordinate. This 3 will be our angle later on, and this y and this 2 will be our y coordinate, or our y intercept. Okay, so this is what I mean by that. Remember, this has a 1 in front of it as well. So you'll see what we mean by this, and this is why this will start to make more sense to you, why it's linear and these aren't. Another note is that you can add linear expressions with or without models. Sometimes you will need to use 0 pairs. Okay, take a look at example 1. Here we're given 2x plus 3 and plus x plus 4. Remember to use associative properties to group them, okay, so that we know that the 2x can be added to this x, and the constants, which is 3 and 4, can be added together. So add the coefficients and then the constant. As you can see down here, they're written in tablets or in tiles. We have 4 terms, and then at the very bottom you can see that 2x and x will give you 3x in total, and 3 plus 4 will give you 7, and here it is written in the most simplest form. And again, okay, you see for example 2 that we have 2x and another x. You remember this x has a 1 in front of it, we just don't write it, so 2x plus another x is going to give you 3x. And then negative 1 plus negative 6, so a negative and a negative being added together will give you a bigger negative number, is negative 6. And there it is. Okay, if you're feeling confident, pause the video now and try A and B, and try to write them in simplest form. Okay, when I see it, I want to line them up. So I line the 3x plus the 2x vertically, and I know it's all being added, so my symbol is being my symbol here is adding, and I just work straight down where I have 8. I bring down my plus sign again, and now I have 5x. Okay, and that's the same expression but in simplest form. Okay, let's try B. Again, I align them vertically. 2x plus 3x, because remember it's plus, negative 4 plus negative 7. So I align them vertically, and I added a plus sign. So now I know negative 4 plus negative 7 is negative 11, and 2x plus 3x is 5x. And there you have it. That's your answer. That's the same thing, just written in simplest form. For example 3, we're going to use as a tactic or a skill called canceling out, where positives and negatives cancel each other out. For example, you can see here that we have a negative x. Well, this negative x is going to cancel out one of these positive x's, and you see all of these positive ones are going to cancel out some of these, or all 3 of those negative x's. So when we do that, we actually are crossing out. So I took this one, and they cross each other out. I took these 3 and these 3 right there, and they cross each other out, and all I have left now is x and 1. So x plus 1. You see it? And for this one, we see, for the question 4, we see that the 2 is outside of the x plus the 3. We can use distributive property where we're going to multiply 2 times x, and we get 2x, and 2 times 3, and we get 6, sorry. And then it's written all like this, so that we can match the pair, so that we have more. If we do the distributive property, then we have like terms, because then we'll have a 2x that can work with a 3x, and we'll have 6 that can be added to the 1. So then once we have that, okay, we have more like terms there, and there, then we can line them up vertically and add. And for example 5 is essentially the same concept, where we use distributive property again to make this expression, or these 3 terms here, look like these 2 terms. Okay, so then we can align them, add them, and remember that we're working with a negative expression, so that you can see that 5x plus 2x is 7x, and negative 20 plus negative 7 is negative 27. Okay, let's try these. Okay, if you're feeling confident, please pause the video now and try it on your own, and then check your questions. Alright, I hope you paused the video. If you didn't, well, then please follow carefully along. That means you don't understand what we're doing. Okay, so for the first term, or the first question, we have to simplify it. I'm going to align the x minus 1 plus, is our expression, 2x plus 3. Okay, and I have negative 1 plus 3, it's going to be 2. Okay, and that's a plus sign there because it's positive 2. And then remember that there's a 1 here. We just don't write it. So it's 1x plus 2x is going to be 3x. And that's it. Okay, let's try D. If you haven't paused the video yet, now would be a good time. Okay, again, I've taken my term and I've aligned them. Okay, and now I'm going to just work straight through. Negative 4 plus 1 is going to be negative 3. And x, positive x, remember, plus negative 2 is going to be negative 1x. Okay, or just negative x. So our answer is negative x, negative 3. Remember, this one is for D. Okay, for E, I will use distributive property to multiply 6 times x and 6 times 7. And that'll give me 6x plus 42. And then I have x plus 3. And all together, it's being added, as you can see right there. Okay, it's all being added. And now just add vertically, where I have 7x now plus 45. Okay, you can place that there. Now let's try f. I have 12x plus 19, and now I will use distributive property here to multiply 2 times x, and I will have 2x, 2x minus positive 2 times negative 10 is negative 20. Okay? And now I will add these two together. So now I have 14x minus to negative 1. So because 19 minus 20 is negative 1. Please make sure you copy all these down and that you show your work as I've shown it. That'll tell me that you're understanding the steps. In addition, please add a star right there to the corner. Okay, that should have been red. There it is. For example 6, we have to write a linear expression in simplest form to represent the perimeter. The perimeter means the distance around it. So we add this plus this side, and that'll tell us the distance all around, around the triangle. Find the perimeter if the value of x is 5 centimeters. So we see every x here needs to be replaced by 5, okay? And then we can solve by adding all three sides together. We can write a linear expression where we have 3x minus 3 right there, plus 2x plus 9 right there, and plus 5x, which is right there. Then we find the like terms, and we use associative property, okay, to combine the like terms. And we have 3x plus 2x plus 5x, and plus negative 3 plus 9. Okay, when we solve that, we have 10x plus 6. And now we can replace the variable with the 5. So now it's 10 times 5, it's 50, plus 6 is 56. So our entire perimeter, the distance around, adding all three, is 56 centimeters. G. A rectangle has sides of x plus 4 feet and x times 2, or 2x minus 2 feet. Write a linear expression in simplest form to represent the perimeter. Find the perimeter if the value of x is 7. Okay, so here's our rectangle, here's our length, and here's our width. Okay, and we know that x equals 7. We can just simply replace 7 in both and solve and then later add. Or we can use an algebraic expression. So I'm going to write an algebraic expression where I'm representing this length twice, because I have it here and I have it here. So I have it here 2x minus 2 times 2, right? And then this length, x plus 4, is represented twice, 2x plus 4. Now let's use distributive property. And I have 2 times 2x is 4x, and 2 times negative 2 is negative 4, plus 2x, 2 times 4 is 8, plus 8. Now I will align these two so I can add them together. And I have 4x plus 2x and negative 4 plus 8. 4x plus 2x equals 6x, and negative 4 plus 8 is plus 4. And there is my simplest form of the algebraic expression. Now I can go ahead and replace the x with 7, because we know x equals 7, and I will do that right here. So it's 6 times 7 plus 4. 6 times 7 is 42, plus 4 equals 46 feet. And that's the perimeter around my rectangle. Don't forget, we're being asked to find the perimeter if the value is 7, so that's our perimeter. But we're also being asked to write a linear expression in simplest form. There's our linear expression in simplest form. Please leave the guided practice for class so we can do it as a warm-up. But complete the entire independent practice, okay? You should know how to do all of this by now if you were paying attention closely. And please do not forget to do the back of the page. We will be checking for this. Okay, see you in class, everyone.